We're going to compute an inverse trigonometry integral. Now at first glance this doesn't actually look like inverse trigonometry, it looks more like a u sub. So we're going to see if that would work. And to check if that would work, I'm going to look at the derivative of the inside of my square root, which is 4 minus 2x. So for the u substitution to work, the numerator would have to be a multiple of that derivative. 2x minus 4 would work, but 2x minus 3 does not. So I'm actually going to use a trick where I break up my integral into the piece that actually would work with a u sub, and then whatever I have to add to make the two equal. Okay. And in order for this to be equal to that, the minus 4 and the plus 1 turn into the minus 3. Now I'm going to do each of these two integrals completely separately. This one, as designed, is a u substitution. Okay. So the numerator is minus 1 du, and the denominator is u to the 1/2, which I can then integrate as minus 2 times the square root of u. In other words, minus 2 times the square root of 4x minus x squared. Normally there's a plus c here, but because I'm going to be adding a second piece to it, I'll just put the plus c at the very end. Now this problem does look an awful lot like an arc sine problem because of the square root of a negative x squared. However, the inside of the square root needs a bit of work. And I'm going to do that by completing the square. It is, however, much harder to complete the square when there's a minus sign on the x squared. So I'm going to change all the signs and complete the square. This gives me x squared minus 4x plus 4 minus 4, which becomes x minus 2 squared minus 4. When I go back to my integral, I have to remember to change my signs back, so it's now 4 minus x minus 2 squared dx. All right, now it looks a little bit more like an arc sine because I have minus something squared. I would prefer this to be a 1 though, so I'm going to use a trick where I factor it out. Now when I factor out a 4 from the square root, it actually becomes a 2, and I'm left with 1 minus x minus 2 over 2 quantity squared, because I had to pull a 4 out of this, and I pulled it as a 2 from the inside. Now I'm going to do a little u substitution here, where u is x minus 2 over 2, so du is 1/2 dx, which I happen to have. So this turns into 1 over the square root of 1 minus u squared du. Namely, it is arc sine of u, which I'm going to go ahead and write as arc sine of x minus 2 over 2, all plus c, and I end up with my complete integral.